All right, everybody. Did you enjoy the last talk? Perfect. Has anybody contributed to open source here? Nice. We have one hand, two hands, three hands, four hands. Yes, we had it. Awesome. We're also always looking for contributors to Shrouding a Hat. So if you have any interesting projects or would like to start contributing, we also have our personal projects. You can find them on the webpage. And yeah, next talk it's going to be by Fiore Vitale, Senior Software Engineer at Red Hat. And the talk is called Dealing with Data Consistency, a CDC Approach to Dual Rights. Welcome, everybody. Welcome. So, is anybody hyped for this talk? Does anybody work with Debezium? No, perfect. So we have one hand. We have one hand over here. Almost. A little bit. That's okay. That's super good. So this is going to be a really good talk to learn about Debezium, especially if you have never heard about it. Me neither. So it's going to be super intriguing how it's going to go. Yeah. Perfect. There are some free spaces over here if you want to sit down. I see here are some chairs, 3 chairs if you want to take a spot. Don't be afraid, we don't bite, so there are 2 spots over here ahead.
Ça?
Perfect. I see there is a lot of people for this talk. There is some spots here free. 1 spot here I see maybe, so if somebody wanted to take a spot. Over here in the 2nd row. The speaker doesn't bite, I think, so you can come forward, no worries. And yeah, I will leave you with Fiore Vitale, Senior Software Engineer at Red Hat. And its talk is called Dealing with Data Consistency, a CDC Approach to Dual Rights.
Okay, I think we can start. So welcome everybody and thanks for joining. And before to start, I would like to ask some questions. So raise your hand if you already know what is change data capture. And who are already using the Debezium? And who is here only for the Fiorentina? So I think that now we can really start. So today we will start to define our problem, and then we will go to different solutions, and we will see how change data capture and the Debezium can help to solve our problem, and then I will show a quick demo and some takeaway. But before to start, let me present myself. I'm Fiore Vitale. I'm a senior software engineer at Red Hat, where I currently working on the Debezium project. And also, I really believe in the open source and in the power of the community. So in the past, I made some contribution to different projects. So if you want to contact me, you can reach my website, where you can find your all contact information. So this is our problem. So we have product services, and that store its product data on its own database. And then we are asking to add also this data to a search index, because we want, for example, expose search functionalities on our e-commerce website. So let's see how we can solve this problem. So the first easy solution is to just modify our application, our services, to do the same operation also on the search index. So every time we modify, insert, or delete a product from our database, we do the same on our search index. This is a very easy solution, so this doesn't require any setup or installation. But the problem is that we want to be these two operations atomic, and since we are writing on two different systems, we cannot rely on database transaction. And so this we can read our solution to have some problem of consistency. Because usually anything that can go wrong, usually will go wrong, and usually will go wrong during the night and the weekend. So let's see how we can avoid this type of problems. Before to start with other solution, I want to give you just the definition of what change data capture is. We are in the area of databases, and so change data capture, also known as CDC, is a set of common software design patterns that permits to determine and track the changes that happen on the database in terms of deltas, and then act on these changes. So let's see now the first solution that is based with this pattern. We are using one of the approach of the CDC that is the query-based approach that you can also see as a batch processing. So what we need to do is to pull the data from our database and move this data to our search index. So the easy solution can be provide a scheduled job that constantly pull the database, take the data, and move this data to our Elasticsearch index. And also for this solution, the setup is minimal. You just need to implement a scheduled job, but we have still some problem. The first one is that we are not able to detect, at least not in an easy way, the deletes, because we need to implement some diff mechanism between the data that are pulling on the database and the data that are still present on the index. Also, we don't have the history of the record states, because we are just taking the current state of the record and updating it on the search index. But there is also another problem that is that required to solve. That is, we need to have a checkpoint mechanism, because every time the job starts, we need to understand where the last job run finished. So we need to implement a checkpoint mechanism. Let's see now another approach that is still based on the CDC pattern, but in this case we are using what is called the log-based approach. That is a more event stream-based solution. So what we have a new component that takes the data from the database log and move this data in a message queue, and then we just need to process these events and do the operation on the search index to move the data. So with this solution, we don't have any impact on the application, because we don't need to modify our application. We have just a low overhead on the database side. And then we are also able to capture also the delete and all the states of the record in the database. As you can see here, we have a C that stands for the create, we have a new that stands for an update, and also we have the delete. So we are able to capture all the changes that we do on the database. And also we are moving to a more modern approach that is more stream-based. The cons is that we need to set up something new, a new component on our architecture. And here is where Debezium comes to help us. So Debezium is a leading log-based change data capture software. It's a fully open source, and there is a very active community, and it's sponsored by Red Hat. And also it's very used in the large production deployment. from companies like Shopify, Vimeo, and Ubisoft, and many, many others. But I said that this solution used to keep the changes from the transaction log. So I don't know how many of you know what information are present inside a database log. In this case, I want to show you an example from Postgres transaction log. And so here we have what we are going to do on the database. So we are doing a transaction and inserting 2 rows inside the data table. How this reflects on the transaction log? So for this particular case of Postgres, you have this type of information. So you have the location, that is also called log sequence number. It's just an incremental ID that identifies your statements on the transaction log. Then we have the XID, that is the transaction ID. And then we have the column data. So in this column data, we have the information of the statement that we are doing. In this case, we are starting the transaction. We have also the ID of the transaction. And also I want to know that all these rows have the same transaction ID because rely on the same transaction. And then we have also the information of the table that we are modifying, the type of operation that we are doing, and also information about the column. So we have the ID column of type integer with the value 1, and also the column data of type text with the value 1. Okay. This is how DB log appears, and this can change between different databases, but more or less the information are these. Let's see now how Debezium transforms this data. We generate what is called a data change event, okay, and that has this form. I have this information, so the message key that usually is the table primary key, and then we have the message value, where we have different information. For example, we have in this case the old and the new record state, because in this case this is an update. So we have information about the state of the row before the update and the after the update. And also we have some additional information, like some metadata. For example, information about the name of the connector, the version, and we have also information about the database, the schema, and the table where these events come from. And also we have what I've seen before, the transaction ID and the log sequence number. Also we have information about the operation that has been done on the database. And here you are seeing just the JSON serialization, but we support also Avro and many other serialization. But how you can use Debezium? Debezium can be used in three different ways. The most commonly used is through a Kafka connector. So for the one that doesn't know what Kafka Connect is just a runtime that you can deploy on your Kafka cluster. And it's just an API over the consumer, the producer API, that permits you to easily move data from a source to Kafka, and from Kafka to a destination. So that this new level of API is called the source connector and sync connector. For Debezium, we are implementing the source connector because we take data from the database and move it to a Kafka topic. But if you don't want to use Kafka, or you have other type of message broker, you can still use Debezium using our Debezium server. That is a standalone Quarkus application, and you can choose where you send your data. So you can choose from different of sync like Kinesis, PubSub, Pulsar, Redis, and many, many others. Or you can also implement your own. And also it's easy to deploy because we have also introduced our Kubernetes or OpenShift operator. But if you don't want to rely also on this server, you can just embed our Debezium engine inside your Java application to our library that have a very small API, and you can just start streaming and receiving the change from your database inside your application, just receiving information in a Java function. But now it's the demo time. So here I have put a QR code just with the link of the repository that I will use for the demo. Are you able to see? Okay, so this is what we want to do today. Okay, so we want to move our data from our Postgres database to Elasticsearch, and we are doing this using Kafka Connect with the Debezium connector and the Elasticsearch connector. So to do so, we need to set up all these components. So we need to set up Postgres, Kafka with Zookeeper, Broker, Kafka Broker, Connect, and the Debezium Elasticsearch, and also Elasticsearch. To do so, I have prepared a Docker Compose file, okay, that I already ran. Let me see here. Where is it? Let me exit for a moment from the presentation view. So I have already run it. Okay, the services are running. I want just to show how it's made. Is the font big enough? Okay. So we have just the Zookeeper. So we have the Kafka. I'm using our images that contain all the configuration in place. And then we are using a Postgres image, Elasticsearch, and just a Connect image that is just built using this Docker file, just because it's a very easy Docker file. It's just starting from our Connect base image that have also Kafka Connect set up. And then we are just adding the Postgres JDBC driver and the Elasticsearch sync connector inside. Okay. So since we are running now, I can show you what is present in our database. So we have these 9 products. Okay. So what we are going to do now is register our connector. So when you have Kafka Connect, you have an API to manage the life cycle of the connector, so you can start a new connector, restart, check the status, and so on. So for example, I can show you using this tool that is just a wrapper of the API. Okay, we don't have any connector installed. So we are going to just install our Elasticsearch connector. Okay, good. And then we are just trying to install also our Postgres connector. Okay, good. So before to see what is happening, I want just to show you how this configuration is made. So this is the source connector. So this is a common way to declare a connector on Kafka Connect. You need to specify a name and a series of configuration. There are configurations that are common for every connector, and that are configurations that are specific for each connector. In this case, we are telling that we want to use the Debezium Postgres connector, and we are giving also information about the database, how to connect to the database. And then there are other stuff that I will not show in this demo, but just to tell you that, for example, here I will just turn to Debezium just to scan the inventory schema. And since when Debezium generates the event, usually we use as a topic name the full qualified name of your table. So in this case, we have inventory.products, and with the prefix differentiate different database or different instance of your connector. But in this case, we are relying on the transformation. That is a way that offer Kafka Connect to apply a transformation on every single message. In this case, we are just saying, okay, every message that is going to a topic that match these regex, just take the last part. So we will have that our messages will go to the product topic. On the other side, we have Elasticsearch Sync Connector. So in this case, we are telling that we want to use the Elasticsearch Sync Connector. There are a lot of connectors already available. And we are telling the address to connect to the Elasticsearch, which topic we want to consume. And then we are just using this transformation that is called unwrap, that since we have seen that the payload of the Debezium is very rich, there are a lot of information, but what we want to move on Elasticsearch is just the part that is inside the after part, so the part related to the row. We are just extracting this part, so that before to pass the message to this sync connector, we are extracting the interesting part. So let's now see what is present on our Elasticsearch. And as you can see, we have all the product inside our index, okay? And let me also show. To show you. Okay, this is what is present inside the Kafka. So this is our products table. And you can see here there is the consumer topic, the consumer group from the Elasticsearch Sync that has 0 lag. So our message has been processed. And I want to show you how a message appears. So we have all the schema information about the message that I will skip for time. And let's see the payload. So in this case, we have the upper part, and I want to focus on this one. This snapshot field that is as this value for the last in the collection, and normally is true, is that when the Debezium starts for the first time, since the transaction log is subject to retention policy, you cannot have all the data inside the transaction log. So the first time we are doing the other approach, so query-based. We are querying the database, take all data, and this approach is called a snapshot, and move all data inside your database. Then we move to the streaming part. We are starting restring on the change. And in fact, you see that the operation here is not a create, but it's just a read, because we read this from the database. So now let's see the power of the real time. So what I want to do now is to insert a new product that is our amazing rubber duck. Okay, and let's see that now this should be already reflected in real time on our Elasticsearch index. Okay, and I want also to show that also here we have our new inserted product, as you can see here. Sorry. It's better now? Okay. So as you can see here, this is an operation create because we have inserted our product, and this comes not from the snapshot. Let's now instead do an update. So we are just changing our description. Okay, and let's see how it's reflected. Okay, so the description has been changed, and also on this side we should have another event that should have the update. Okay, in this case we have also the status of the record before and the status after. I did two updates, so this is why you see the same changes. And let's see the last one. So we are going to delete our beautiful rubber duck because we want to be the only one to have it. So let's now, let's now see. Okay, we don't have our rubber duck anymore on the search index. Let's see also how this reflects on our topic. Okay, we have actually two records. The one is the delete. As you can see here, you have the operation D. You don't have the after, just the before. And then we emit also another message that is called a tombstone that permits you to rely on the Kafka compaction. Because when you emit for the same message key, a null message permits the Kafka to delete the oldest message with the same key. So let's go back to the slide. So we have seen how CDC can be a very powerful partner to enable you starting your data changes from your databases. And we also see how Debezium can permit to easily do this. And it supports many databases like DB2, MySQL, Postgres, Oracle, SQL Server, MongoDB, and many, many others. So I have finished it, so I am open to receive questions. But before, I want to leave with this slide. So there are some links if you want to know more about Debezium, and if you want to contribute, we are always open to receive contribution. And I just leave this form. If you want to give me a feedback, it will be very appreciated. Thank you.
All right, everybody. Another big round of applause for Mario, please. This is your trophy, Mario. Thank you very much for being a speaker. Was this your first talk?
Yeah.
Oh, nice. How do you feel about it?
It was good. The first online, but it's not the same experience.
No, of course not. Of course not.
Yeah.
So, does anybody have any questions for Mario? Come on, don't be shy. Perfect.
Hello. I'm very curious I'm very curious to understand if it's possible to perform some kind of enrichment in the line, or this tool can only execute the same transaction on another connector.
Yeah, you can do the enrichment with the transformation that we saw before. So you can implement your own transformation and apply something on your on single record if you want to add something or doing other enrichment operation, or if you are referring to like joining and booting this data, you can rely on streaming framework like Flink, for example, where you can take data from different topic, merge it, and then produce your final changes.
Okay, and in the context of open sourcing, it's possible for everyone to create a new connector.
Also for the Kafka Connect, you can create your own connector.
Okay, thanks.
Any more questions?
In the search JSON file, the password, the credential, user, and password are in plain text. There is a way to load from like environment variables.
As far as I know, I think no. Also because this file is just for the first time registration, so it's a file that you need to provide for register it for the first time. So usually you should not provide it in an unsafe way. But I honestly don't know if there is this possibility. Maybe yes, but I'm not aware of it.
Thanks.
Thank you.
Perfect. Anybody else? Another question? Perfect.
Hi. I might have been technical enough for the details, but I understood in your third flow that you got the trigger for the change from the log, right? There is a database log somewhere here.
Yeah.
So I was curious to understand if, because for sure we need a trigger, like this record has changed, but can you have the same trigger just comparing your database with the index, or you necessarily need the log from the database?
I don't
Is
really
my question
understand.
clear?
No.
No, okay. You know that the record has changed.
Okay.
You can detect this from the database log.
Yeah.
Yes. Or if in case you don't have the database log, can you compare your new record the database versus the index?
Yeah, but you are in this
I
other
am in this
approach.
scenario here.
Yeah.
Okay.
You need to do it in your own.
Okay. So the best practice is that you detect the change from a database
And just
level.
reflect it on the
Okay, got
index.
it.
Yeah. Thank you.
Perfect. Does anybody have any other questions? Here we go. All the way at the back. Tukutun, tukutun, tukutun.
Maybe I'm getting into too much into the DB log part, but do you know if we can add some sort of metadata when we run the query so that it appears on the DB log and we can add more information into whatever secondary source that we have? Or if we can't do that, can
So-
we add more data asynchronously? For example, if we do some sort of update, let's say, and we want to add who was the user or who was the responsible for doing that update, which is something that doesn't normally appear on SQL. Can we add that data synchronously or maybe pulling from the database?
You are asking if you can add data directly on the log. No.
Okay.
But for example, Postgres has the ability to insert programmatically some changes on the transaction log. But
Okay.
as I know, only Postgres has this feature as of now.
Okay.
So you can just use a function to write directly on the transaction log.
Okay. Perfect.
Thank you.
Perfect. So I do have two questions from my own. The first one, how much would it cost for a software engineer? How much knowledge should a software engineer have to move to Debezium to utilize it?
I need to say that yesterday was my first year on this project, and so I just made a lot of contribution because we have a very good documentation and also we have a very powerful community. So if you ask something on our Zurich chat, you will be sure that someone will answer you and will guide you with different aspects. We have also contribution from Google that created their own connector for the spanner. So we are going to help anyone. So it's easy. At least you need to know something about this area, but it's not so difficult, except for the part that are very near to the transaction log. But mainly, it's easy to start.
Perfect. All right. Give it up for Mario once again.
Thank you. Thank you.